If you are not able to make it to the lesson, I just wanted to make sure that you got the lesson. So on parallelograms, which is actually spelled like this. So on parallelograms. So I'm going to just kind of go over 6 properties, not kind of, I am going to go over 6 facts about parallelograms, and then I'll show you what it means, and then we're going to practice it. So first, here are the facts about parallelograms. And you could say some of them are theorems. I know they are. Some of them are not theorems. They're just properties, but here we go. The opposite sides of a parallelogram are congruent. I'll show you what this means. The opposite angles are congruent. The consecutive angles, the angles right next to each other, are supplementary. They add up to 180. The diagonals of a parallelogram bisect each other. And then each diagonal separates the parallelogram into 2 congruent triangles. And then if one angle is right, then all the angles are right. So that's kind of what that means. So now I'm going to jump out of here and then show you what that means in here. So here are our properties, and I wanted to show you how it goes. So let me see if I can switch this. Okay, so here are these properties, still here. And I wanted to show you what this meant. So if we had this parallelogram A, B, C, D, then the opposite sides are congruent. So let me just show you with measuring the length. If I measured this side and that side, notice they're the same length. Or if I measured this side, this side, or that side, they're the same length. And even if I were to take this and change something about it, notice it's still a parallelogram. They are still the same length. Or if I take one of these sides and move it, it's still going to be the same length. Let me move it back up. Okay. Then we have that the opposite angles are congruent. Here, let me hide those things first. Okay, so we're going to measure these angles. If I measured from A to D to B, I went the other way around. So these two are the opposite angles if they're on the opposite, like diagonally across. And then we would just want to show what they were, like the measurement. Well, I'm going to show what they were. So that's the measure of that one. And it's the same thing. Oops, if I can get it for that one. So they're both 110. Even if I were to move this and change the size and the shape of this thing, it's going to stay the same. Or change the angles, it'll stay the same. They'll still be congruent. And then another thing is that they are consecutive. They're consecutive, meaning one right after the other. Another word for that is adjacent. And they're supplementary, meaning that they add up to 180. So if I were to measure this, then I could say from C to B to A, that measures to be this. Or if I measured from A to D to C, it also is the same thing. And once again, if I were to move those, they were to do that. But then if we were to add these two, so 84 point blah, 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 well, basically 84.5 plus 95.5, if we were to add those up, so, oh, cool. I'll do this a different way. So rather than showing it that way, I just want to show you if I were to do this and say, go to Desmos, my favorite graphing calculator. I'll use the scientific calculator. Okay, so if we did 95.5 plus 84.5, you'll notice it equals 180. So those two are always going to be adding to 180. Even if I were to grab it and move it around and change those numbers, it will still add up to 180. And then next thing we have is each diagonal of a parallelogram separates into 2 congruent triangles. Now I'm just going to show you this. There are proofs of this, but I'm just going to show you this. So first thing I'm going to do is I'm going to create a segment that makes it the diagonal. So from here to here, and from here to there. Those are the diagonals. So by definition, the diagonal is the one that goes diagonally across the shape. Got rid of those little things there. And then we did the intersection between those 2 points. Then again, we can measure stuff. So I'm just going to show you the measurements there. Again, there are proofs of these things, but we're not doing that right now.